So our next question is, three identical heat conducting rods are connected in series as shown in the figure. The rods on the sides have thermal conductivity is 2K, while that in the middle has thermal conductivity K. The left end of the combination is maintained at temperature 3T and at the right end at the T. The rods are thermally insulated from outside. In steady state, temperature at the left junction is T1 and that at the right junction is T2. The ratio T1 by T2 is. So here, because of this different temperature regions, there may be a chance of flow of heat from this end to that end. So after steady state, every substance will get the same heat, but the storage of that heat will be different because of their conductivity. So first of all, we will find the heat transferred from this system to that system. We have a formula in the textbook, like the heat transferred delta H is equal to heat conductivity K cross sectional area A into T2 minus T1 divided by L. Through this cross section, the heat is flowing from this end to that end, because here temperature is higher, so heat will transfer from this end to that end. Because it is given that all three are identical in shape, so we can take same length and same cross sectional area, but only the difference is the conductivity. Now using this formula, we can find the heats that transferred to reach the steady state. So in first one, delta H1 is equal to 2K into A into 3T minus T1, because T1 is given here, and by L. Delta H2 is equal to K into A into T1 minus T2 by L, and delta H3 is equal to 2K into A into T2 minus T divided by L. At steady state, the heat transferred will be same in all three substances, so we can equate those things. By equating those things, we will get a relation like 2 into 3T minus T1 is equal to this T1 minus T2, if you compare these two first, and next from this we will have 6T minus 2T1 is equal to T1 minus T2. So on a whole, I will have 6T is equal to 3T1 minus T2. If you compare these two equations, you will have T1 minus T2 is equal to 2T2 minus 2T. So I want the equation to be settled to T, so bring this 2T to the side. So 2T is equal to 3T2 minus T1. If you take the ratio of these two, because I need to eliminate the T term, because we need to find out T by T1 by T2. So if you eliminate T term here, so 6T by 2T you will have 3, which is equal to 3T1 minus T2 by 3T2 minus T1. If you take the cross multiplication, you will have 9T2 minus 3T1 is equal to 3T1 minus T2. So it will be 10T2 is equal to 6T1. So from this, T1 by T2 is equal to 10 by 6, which is 5 by 3. So the answer is the fourth one, 5 by 3.